Hi, this is Mr. Fraser. We're going over lesson 5.1 and 5.2, things that you should already know, but this is a brief review. First of all, you're going to be using the distance formula anytime you have anything on a graph. Okay? So that means anything that's on a coordinate plane, you'll be using the distance formula to find the measure of the lengths of certain sides. All right? So our first definition is mid-segment. Hopefully you understand a mid-segment is where you connect two midpoints. So you're still paying attention to the congruency marks. They are the most important part of any picture we do. You're constantly looking for congruency marks. This is a midpoint because of the congruency marks. This is a midpoint because of the congruency marks. When you connect two midpoints, you have a mid-segment. So fill in the definition of mid-segment. The second thing is in 5.1, we are just reviewing two rules, and we've talked about these. The first rule is the mid-segment of any triangle is always parallel to the third side. So we're saying that the mid-segment is always parallel to the third side of the triangle. And then the other part has to deal with the actual length of the mid-segment. The length of the mid-segment is always half of the third side. So I tell people to always do 2 times the mid-segment, and you would set it equal to the third side. And this way you'll always get the math correct. When you try to do 1/2, you will have a tendency of getting equations that are here, and you won't know what to write. Because you'll try to divide the equation by 2, which is not what you should do. You take what this is here, the third side, you put it equal to 2 times the mid-segment. So whatever the third side is equal to 2 times the mid-segment. And it would look like this. Okay, that's 5.1. 5.2 deals with perpendicular bisectors, and we talked about this at the beginning of the year. We said it worked like an umbrella, that as you open and close an umbrella, the distance from wherever you stop when opening the umbrella to the corners is always the same distance. Okay, so in other words, we're trying to say that anytime you have a point on the perpendicular bisector, is always the same distance to the end of the segment being bisected. So that means this distance and this distance are congruent, this distance and this distance are congruent, this distance and this distance would be congruent. Okay, because they're coming from the same point on the perpendicular bisector. So that's the rule that works with perpendicular bisectors. That when you have a perpendicular bisector, any point on that perpendicular bisector will always be the same distance to the endpoints of the segment being bisected. Okay, so it's important to understand what a perpendicular bisector is. It's perpendicular, which is that mark, and it bisects, which are these congruency marks here. Okay? So you have the definition of perpendicular bisector, and then its rule. And that rule is any point on the perpendicular bisector is equidistant to the endpoints of the segment being bisected. All right? And then last but not least is an angle bisector. The definition of that, hopefully you know it's a ray that cuts a line segment, or excuse me, that cuts an angle into 2 equal pieces. Okay, so that's where the congruency marks come from. So in other words, angle bisector, these congruency marks are important. Again, the congruency marks are the most important thing. Then the rule we learn with angle bisectors is that any point on the angle bisector, just like any point on the perpendicular bisector, any point on the angle bisector is perpendicularly equidistant to the side of the triangle. So that means if I stop here, this is the same distance perpendicularly to here and here. Right? So if you're on an angle bisector, you're the same perpendicularly equidistant to the sides of the angle. Okay. Any point on the perpendicular bisector is equidistant to the ends of the segment being bisected. Any point on the angle bisector is perpendicularly equidistant to the sides of the angle. The key is it has to be perpendicular. If it's not perpendicular here, then they're not equidistant. If they're equidistant, then they're perpendicular. If they're perpendicular, then they're equidistant. If they're not perpendicular, then they're not equidistant. If they're not equidistant, then they're not perpendicular. So this is where that if-then worked in, and we talked about it. So you're looking for one thing on the congruency marks so that you can use the other. So these two equations would be equal, or these two problems would be equal. But you're looking for this to help you, or you're looking for this to help you. So if you have this happening, then you can say the line here is a perpendicular bisector or angle bisector, and you can work backwards. So like if they give you a picture that only has that much information on it, you know you can add the congruency marks because you know that is a angle bisector because it's perpendicular and equidistant to the sides of the angles. So knowing it forwards and backwards. Forwards is our theorem, backwards would be our converse. All right, good luck on the work.